Hi team, welcome back to question 3 on the 2017 paper 2A. Sponsors are here, Grays Hockey. Let's get into it. So William teaches English. His class sat an exam. The marks of the students can be modelled by a normal distribution. Which of the following diagrams shows a normal distribution? Well, it's this wonderful bell curve shape here in the middle. This one at the top is skewed to the left. The one on the right skewed to the right, and the one in the middle just looks like a rectangle who's lost its way. So, part B. The marks have mean 65 and standard deviation 11. According to the model, 40% of his students scored more than M marks. Work out the value of M. So on our graph, there we go. That's our diagram. 0.4 or 40% of his students scored more than so many marks. So that means we're looking at the right-hand side of the curve, and then this value in here is 0.4. So we want to do the inverse normal. And we've got our mu value to be 65, and our standard deviation is 11. And then we want to have the right tail to have an area of 0.4. Plug all that into the calculator and it will give you 67.7868181. And we always truncate these values, giving us an answer of 67 pupils, because if we had 68.1, it would be 68. That's not quite 68, so we go down to 67. Okay, part C. There are 30 students in William's class. Students who score more than the mean mark in the exam will each receive a voucher worth £5 as a reward, right? William uses the normal distribution model to conclude that it will not cost him more than £70 to reward these students. Is William correct? Now the mean is there, and the mean value is always 0.5. So we have 0.5 here, 0.5 here, meaning that half of his class are going to pass. If I'm honest with you, I'd be expecting more to be, well, it's not pass, is it? But it's about getting more than the mean. So 15 of those pupils are going to get more than the mean. We multiply that by £5, and it gives us £75, meaning William is incorrect. Sadly for William, he's going to be out of pocket. Okay, part D. Other students in the same year group will sit the same exam. The pass mark for the exam is 60. If the distribution of their marks matches that of William's class with a mean of 65 and a standard deviation of 11, approximately 140 of these students are expected to pass. How many students are there in total in the year group? So we've got our curve there, and then our value of 60 is going to be in that position because 60 is less than the mean. And then within this bit here, this is 140, that value. So we're going to need to know the probability of this value being greater than 60. So what we put into the calculator is the mean of 65 again, standard deviation of 11. We're going to put a low number of 60, and then for the high number, I just went silly and put 10,000. That came out at 0.67528185. Now, this is kind of like reverse percentages because we've got a population, which I'll call X. It's been multiplied by 0.67528185, and its answer is 140. So we're going to need to divide 140 by the 0.675 ... By doing that, it gives us 207.3208, which is 207. But that's not all, because it says how many students are there in total in the year group. So we need to add William's class to this, giving us 237 pupils. Okay, I hope this has been useful. I'll see you guys at question 4.